How did the physical limitations of the fragile human neck force the creation of the world's very first fully robotic, science fiction ghost port? This is Critical Path, where we explore stories and innovations about our global supply chain that connect our world to your everyday life. Imagine, if you will, a scenario where the entire global economy is essentially a giant, unimaginably high-stakes game of Tetris. But instead of brightly colored, pixelated neon shapes floating down a screen, the blocks in this game are 30-ton steel containers. And the game board? Well, the game board is a freezing, salt-lashed patch of mud teetering on the edge of the North Sea. Welcome to the late 1980s at the Port of Rotterdam. By this point in history, the people running the port were staring at a metaphorical screen that was filling up far, far too fast. Global trade had hit what we will call level 99 speed, and it was threatening to turn the world's then busiest maritime hub into a gargantuan, rust-colored bottleneck. You see, the container revolution, the grand, sweeping promise of a future defined by seamless logistical efficiency, was beginning to look a lot less like a synchronized ballet and a lot more like a chaotic urban sprawl. Shipping lines, entirely drunk on the sheer volume of international trade, were commissioning what they lovingly called megavessels. These were behemoths capable of carrying thousands of containers at a single time. But here was the hilariously fundamental flaw in the grand plan. While the ships were getting bigger, the methods for unloading them remained stubbornly, painfully analog. To get those mountains of steel off the boats, the port relied on a small army of heavily caffeinated dock workers, manual crane operators, and diesel-chugging truck drivers. These people were expected to move literal tons of metal with the precision of a Swiss watchmaker, but the sheer volume of trade was creating immense peaks and troughs in the workload. A human workforce, no matter how dedicated or how much coffee they consumed, simply could not smooth out those spikes. If a ship carrying 4,000 containers, which was considered a towering giant for its time, had to sit around waiting for 3 days to be unloaded because the humans were simply too slow to move the metal, the shipping lines would absolutely throw a fit. They would pack up their business and sail right over to Hamburg or Antwerp, leaving Rotterdam in the dust. Rotterdam was facing what industry insiders dramatically called the logistics wall. The port was nearing its absolute physical capacity. The cost of labor was spiraling out of control. And the traditional response to this kind of problem, which was usually just hiring more people and paving over more land, was hitting a brutal ceiling of diminishing returns. The challenge they faced was seemingly impossible. How on earth could the port triple its capacity, significantly reduce costs, radically improve safety, and fight off the relentless encroachment of a rising ocean, all at the exact same time? The solution, as it turns out, would require a radical, bet-the-farm gamble on a futuristic vision where the humans would politely step back, and a ghost army of autonomous robots would take the reins. But to truly understand how Rotterdam became a multi-billion-dollar playground for autonomous robots, we have to rewind the clock. We have to appreciate the delightfully unhinged, long-standing Dutch tradition of looking at a violently churning ocean and deciding, against all laws of nature and common sense, that it would make a really lovely place for a parking lot. The history of Rotterdam is a 700-year narrative of strategic adaptation and absolute engineering hubris. The name of the city itself literally originates from a dam that was built on the River Rot around the year 1270. It was a modest little act of water management that transformed a tiny, soggy fishing village into a nascent trading hub. By the year 1360, the settlement had already begun its grand tradition of deciding geography was merely a suggestion. They constructed a canal to the Schie, allowing Rotterdam to bypass the annoying local river silt and connect directly with larger, more established cities to the north, like Delft and Leiden. This early role as the ultimate middleman, moving English wool to German markets, laid the absolute bedrock for the port's eventual status as a global gateway. During the Dutch Golden Age, which spanned from 1588 to 1672, Rotterdam absolutely flourished as a bustling center for shipbuilding and colonial trade. They leveraged the Republic's maritime dominance to grow their population and their massive ambitions. However, the modern era of the port, the one that really sets the stage for our robot overlords, truly began in 1872 with the opening of the Nieuwe Waterweg, or the New Waterway. Before 1872, ships desperately trying to reach Rotterdam had to navigate a miserable labyrinth of shallow, silted-up river arms. It was like trying to drive a semi-truck through a muddy corn maze. The New Waterway provided a direct, deep water link straight to the North Sea. It acted as a massive catalyst, shifting the port from a traditional staple market, where they focused on carefully storing high-value spices and textiles, into a high-volume transit port, specializing in the heavy, dirty raw materials of the Industrial Revolution, like coal, ore, and petroleum. And then, everything changed again in May of 1966. A ship named the MS Fairland arrived in Rotterdam from New York. It was carrying a mere 226 containers. At the time, it probably looked like a modest little shipment, but it was the quiet beginning of a global revolution. The humble steel container became the best invention of the past 100 years, standardizing global trade. Eventually, that tiny 226 container shipment would pave the way for ships carrying over 24,000 containers entering those exact same waters. As the container took over the world, the port began a massive westward migration toward the sea, literally building new land directly on top of the North Sea to accommodate the ridiculous scale of global logistics. Which brings us back to the early 1980s, and the terrifying reality of the logistics wall. Gerrit Wormmeester was the director of Europe Container Terminals, or ECT. If you want a good mental image of Wormmeester, picture the visionary energy of a 1980s tech mogul, but applied to the decidedly unglamorous world of maritime shipping. He was a guy who looked at a massive problem and decided to solve it with science fiction. He realized that the traditional, highly labor-intensive model of port operations was fundamentally, irreparably broken. In 1983, ECT handled 1 million containers for the very first time. That sounds like a massive victory, right? Wrong. The costs were rising significantly faster than the volumes. They were moving more boxes but making less sense financially. And then, Wormmeester had his massive revelation. It was an idea that was simultaneously elegant and utterly terrifying. He concluded that to survive the coming decades, the port needed to entirely eliminate human variability from the quayside. Now we have to pause and appreciate how completely insane this sounded in the mid-1980s. The port sector was incredibly traditional. The technology required to fully automate a massive container terminal did not actually exist anywhere on planet Earth. There were no self-driving cars driving around California for them to study. The complex software required to coordinate dozens of massive, building-sized machines in real time was pure fantasy. It was like pitching a smartphone to someone in the Victorian era. But the impetus for this radical shift wasn't just some abstract desire to be cool, it was a desperate commercial crisis. Sealand, a massive American shipping line and ECT's single largest customer, was actively being courted by other European ports that were offering lower and lower rates. Instead of entering a miserable race to the bottom on pricing, where everyone just cuts costs until the service is terrible, ECT chose to distinguish itself through extreme innovation. They literally proposed building a fully automated, state-of-the-art terminal at the Maasvlakte. Sealand, presumably thinking this sounded awesome, accepted the proposal in 1987. They gave the Dutch exactly 5 years to build the future. No pressure. The technical challenges were absolutely staggering. The team, led by their Director of Technology Johan Rijsenbrey, had to invent automated guided vehicles, or AGVs, completely from scratch. These autonomous vehicles needed to confidently carry 70-ton loads of steel and navigate around a busy terminal with centimeter precision, all without a human driver. Simultaneously, they had to invent automatic stacking cranes and write the unfathomably complex control software needed to orchestrate this mechanical ballet. After years of agonizing teething problems, intense testing, and probably a lot of sleepless nights, the ECT Delta terminal was officially opened on the 25th of June 1993 by Queen Beatrix herself. It was the absolute first fully automated container terminal in the history of the world. It was an engineering milestone so ridiculously ahead of its time that it would not be successfully imitated anywhere else on the globe for nearly a full decade. Now, if you walk onto a modern, fully realized Rotterdam terminal today, like the Rotterdam World Gateway or APM Terminal's Maasvlakte 2, it is a deeply eerie experience. If you are accustomed to the romanticized image of a traditional dock, the shouting of foremen, the clatter of steel, the roar of diesel engines, the chaos of human activity, you are in for a shock. It is a ghost port. The air is incredibly quiet. The machines are entirely electric. The only humans you are likely to see are wearing business casual clothing and sitting comfortably in climate-controlled offices blocks away from the actual water. The movement of a container from a ship to a truck is a multi-stage, flawlessly executed robotic ballet. The first massive actors in this silent play are the ship-to-shore cranes, or STS cranes. These are absolute giants, standing nearly as high as the famous Erasmus Bridge in Rotterdam. Now, in a traditional, non-ghost terminal, a human crane operator sits in a tiny, terrifying little cabin suspended 50 meters in the air, peering down through a glass floor to snag containers off the ship. It is a job that requires nerves of steel and a stomach for heights. But at Maasvlakte 2, many of these cranes are completely cabinless. There is no tiny glass box. There is no human dangling in the sky. The operators sit miles away in a cozy control room inside the main terminal building, supervising the giant cranes via high-definition camera feeds that actually provide views far more comprehensive than those available from inside a physical cabin. These robotic cranes are equipped with incredibly advanced dual-lifting technology and tandem spreaders. This means they can casually reach down and snatch up two 40-foot containers at the exact same time. And because there is no fragile human meat sack on board to be violently jostled around by rapid, jarring stops, the cranes can accelerate and decelerate at substantially higher rates, significantly shortening the time it takes to unload a ship. And this right here brings us to the most massive, counterintuitive revelation of the entire story. The absolute biggest, neon-flashing, mind-blowing twist on why this automation was actually necessary. When most people look at a highly automated facility, they naturally assume that robots replace the humans because robots are cheaper. They don't need healthcare, they don't take lunch breaks, and they don't complain. And sure, while controlling labor costs is certainly a factor in any business, the real, foundational reason Rotterdam went robotic is far more surprising and, frankly, a bit horrifying. Human biology literally became a physical bottleneck for global trade. As container ships absolutely exploded in size, growing from carrying 4,000 containers to a mind-boggling 24,000 containers, the cranes required to reach across and unload them had to become massively taller and significantly faster just to maintain basic efficiency. To move a container from the far side of a 60-meter wide megavessel all the way to the quay in under 90 seconds, the crane's trolley has to accelerate and then slam to a stop with violent, bone-rattling force. If a human operator was sitting in a cabin on that trolley, riding it back and forth over the ship, the repeated, aggressive G-forces would cause severe, debilitating injury to their neck and spine over the course of an 8-hour shift. Furthermore, think about the posture. A human sitting 50 meters in the air has to look straight down through their legs at a brutal 90-degree angle, just to see the container they are trying to grab. The human neck, as wonderful as it is for looking at clouds or nodding politely in conversation, was simply not designed by evolution for 8 hours of vertical downward staring while simultaneously being subjected to high-speed horizontal rattling. By moving the operator to a comfortable remote office and using an array of cameras, the crane is finally allowed to operate at its true mechanical limit. It moves with a speed and an aggression that would quite literally give a human driver extreme whiplash. In a very real, scientifically verifiable sense, the ship simply became too big for the human body to handle. The robots aren't just faster than us, they are the only things physically capable of surviving the job without having their spines shaken to dust. So, the giant crane snatches the container without giving anyone whiplash. What happens next? The crane lowers the container directly onto an automated guided vehicle. Remember those AJVs Johan Rijsenbrij's team had to invent from scratch? Today, they are magnificent. They look like giant, boxy, completely driverless skateboards that can casually carry 2 containers at a time. The navigation of these vehicles is a masterpiece of invisible infrastructure. At the older Delta terminal, they use a massive magnetic grid. There are literally thousands of transponders buried directly into the terminal tarmac. The AGV's onboard sensors read these buried magnets to figure out its exact coordinates on the grid, while an inertial navigation system fills in the tiny gaps between the transponders. It is basically a giant, heavy metal Roomba. At the much newer APM terminals Maasvlakte 2, the lift AGVs are fully electric and produce zero emissions. And these vehicles don't just carry the containers around, they have the ability to literally lift themselves up and place the containers into storage racks. This simple trick decouples the giant crane's operation from the vehicle's schedule. The crane doesn't have to wait for the car, and the car doesn't have to wait for the crane. And when these massive electric chariots run low on juice, they absolutely do not call a human for help. They drive themselves over to a designated battery exchange station, where a giant robotic arm casually reaches out and swaps their massive 12-ton battery for a fresh one in exactly 5 minutes. It is a Formula One pit stop, but with 0 humans and a whole lot more tonnage. The final stop for our heavily traveled container within the terminal is the stack. This is essentially a massive, open-air library of steel boxes, obsessively organized by automated stacking cranes, or ASCs. These cranes run constantly on massive rails and are entirely responsible for sorting the containers based on how they are leaving the port, whether that is by truck, by train, or by a smaller barge. The ASCs are the meticulous librarians of the operation. Their entire job is to ensure that a container scheduled for a truck pickup at 2 in the afternoon is not accidentally buried underneath 5 other heavy boxes that aren't leaving until Thursday. To achieve this, these cranes move containers in a constant, hypnotic rhythm during the quiet, dark hours of the night. While the rest of the country is sleeping, the robot librarians are reorganizing the stacks to perfectly optimize the very next day's throughput. But if the AGVs and the giant cranes are the bulging mechanical muscles of the port, the software running it all is the hyper-advanced prefrontal cortex. In Rotterdam, the industry-standard brain is a software suite known as Navis N4. It plans the movement of every single container from the exact moment a massive ship enters the Euroduel, which is the heavily dredged deep water channel out in the North Sea. However, the real, heavily guarded secret to Rotterdam's flawlessly fluid movement is a highly specialized layer of software called TEMS, which stands for Terminal Equipment Automated Management System. Developed by a brilliant Dutch firm called TBA, TEMS is essentially a ridiculously high-stakes, real-time traffic controller for a city of robots. It takes high-level, basic commands from the main brain, like, for example, bring container A over to rail track 4, and it translates that simple command into hyper-precise, incredibly complex driving paths for the AGVs. Now this sounds simple enough, until you realize that at any given moment out on that tarmac, there are 60 individual vehicles, each weighing 70 tons, zipping around at 20 kilometers per hour in a space roughly the size of several football fields. The primary job of TMS is to relentlessly prevent what engineers call deadlocks. A deadlock is a digital standoff where 2 massive robots meet at an intersection, and due to conflicting programming, neither one knows how to safely move without smashing into the other one. It is like when you do that awkward hallway dance with a stranger, except if you mess up, thousands of tons of steel collide and ruin millions of dollars of cargo. To prevent this, the software uses incredibly advanced collision avoidance logic. It digitally partitions the entire physical terminal into a massive, invisible grid of tiles. The software ensures that only one single robot is mathematically authorized to occupy a specific tile at any exact timestamp. It is a glorious form of industrial swarm intelligence. This flawless digital orchestration allows the port to operate 24 hours a day, 7 days a week, even in incredibly dense maritime fog or a driving rainstorm that would completely blind a human truck driver. Now you would think that with all this robotic efficiency, the Dutch would be satisfied. But by the early 2000s, even the massive, expanded port was getting too crowded. Rotterdam was rapidly nearing its absolute growth limit. The country was out of space. So they concluded that the only logical way to expand the port was to literally push further out into the violent ocean. This leads us to the awe-inspiring construction of Maasvlakte 2. This wasn't just a construction project. It was essentially a project that involved adding a staggering 2,000 hectares of brand new land to the total size of the Netherlands. The engineering required for Maasvlakte 2 was a true spectacle of Dutch waterbending prowess. They brought in the exact same massive dredging fleet that successfully built Dubai's famous Palm Islands. They used these colossal ships to literally suck sand straight from the seafloor and spray it in massive, glorious arcs onto designated areas to slowly build up the height of the ocean floor until it became dry land. Of course, you can't just pile up sand in the North Sea and expect it to stay there. The ocean is aggressive. To prevent the sea from simply washing their brand new expensive land away, they armored the entire perimeter with a massive 4-kilometer dike and 20,000 absolutely gigantic stone blocks. Maasvlakte 2 was intentionally designed from day one to be the world's most advanced, forward-thinking container hub. They widened the deep water channel and deepened it to a staggering 20 meters to ensure that ultra-large container ships could effortlessly dock at absolutely any time, regardless of what the tide was doing. But it gets better. The terminals out here are not merely automated, they are a shining global flagship for the energy transition. The APM Terminal's Maasvlakte 2 facility is an entirely CO2-free terminal. Every single electric vehicle, every giant robotic crane, every computer system is powered entirely by a massive €5 million energy contract utilizing wind energy generated right there in the North Sea. They are using the wind of the ocean to unload the ships on the ocean. Now, while this grand narrative of robots, artificial intelligence, and wind power is undeniably thrilling, the massive transition to automation was certainly not without its human glitches. The Port of Rotterdam has a very long, very militant, and very proud tradition of industrial conflict. In the early 1990s, when Wormmeester's grand plans for the very first fully automated terminal were loudly announced, the dockworker unions were, quite understandably, significantly less than thrilled about the prospect of being replaced by magnetic robots. Strikes were highly common, and the powerful Vervoersbond FNV union quickly became a massive, undeniable force in negotiating the specific terms of this terrifying technological change. But this is where the Dutch employed their characteristic cultural superpower, the polder model. This is a deeply ingrained system of consensus building, where everyone sits around a table and talks until they reach an agreement. Instead of initiating a brutal, dystopian wave of mass layoffs where thousands of people lose their livelihoods overnight, the Port Authority and the labor unions painstakingly negotiated the Master Plan of 1989. This groundbreaking agreement strictly ensured that there would be absolutely no compulsory redundancies for several years. Instead of firing people, they utilized the port's massive pension fund to finance very comfortable early retirements for roughly 1,200 of the older workers. However, for the workers who stayed, the very nature of their work changed fundamentally and forever. Historically, a traditional dock worker's job was incredibly physically grueling, horribly dangerous, and exposed to terrible weather. Today, a modern wharfie working in Rotterdam is substantially more likely to be a highly trained data specialist or a remote crane supervisor, sitting at a desk with an ergonomic chair and a cup of hot coffee. Even a terminal that proudly bills itself as fully automated still requires humans to function. It currently employs over 600 people. These are the mechanics who fix the giant robots, the lashing gangs who secure the cargo, the high-level supervisors, and the incredibly important exception managers. These are the clever humans who have to step in and manually take over when the artificial intelligence gets confused by a weirdly shaped box or a sensor glitch. As researchers studying the port have astutely noted, the final outcome of heavy industrial automation is never actually a pure technical inevitability. It is always a complex political decision about exactly how to distribute the massive productivity gains between the people who own the capital and the people providing the labor. Rotterdam chose a path of negotiation rather than devastation. So with all these robots, all this new land and all this wind power, how does Rotterdam stack up against the rest of the world? In the highly competitive global arena of container ports, size and success are traditionally measured in sheer volume, specifically TEU throughput, which is just a fancy way of counting how many 20-foot boxes you move. And on this specific metric, the world's absolute crown undeniably belongs to the mighty ports of the East. Massive Asian hubs like Shanghai, which casually moves an earth-shattering 51.5 million TEUs, and Singapore, which handles a staggering 40.9 million TEUs, exist in an entirely different stratosphere of volume compared to Rotterdam. In 2025, Asian ports completely dominated, accounting for over 40% of absolutely all global container traffic. Rotterdam, by comparison, moved a highly respectable but comparatively smaller 13.4 million TEUs. However, the Port of Rotterdam Authority has explicitly and repeatedly stated that their ultimate goal is no longer about sheer size. They know they can't outbox Shanghai. Their goal is entirely focused on quality. While many of the massive Asian ports still rely heavily on gargantuan labor pools and semi-automated systems, Rotterdam has deliberately and aggressively positioned itself as the smartest port on the planet, and the industry recognizes this. In the 2025 Global Container Port Benchmark Report, while Singapore ranked first overall globally, Rotterdam proudly emerged as the highest-ranked port in all of Europe, coming in at 5th place worldwide. They scored exceptionally high in crucial categories like sustainability, thanks to those zero-emission wind-powered terminals and hinterland connectivity. That hinterland connectivity is actually Rotterdam's true, unbeatable competitive advantage. It is all about location. Sitting perfectly at the mouth of the Rhine River, the port is intimately connected to the Betuwe route. This is a massive, incredibly expensive, dedicated freight railway that stretches for 160 kilometers. It allows endless lines of containers to travel directly from the Dutch coast deep into the industrial heart of the German Ruhr area, without ever encountering a single passenger train or a solitary traffic light. While a megaport like Shanghai might move significantly more boxes on paper, Rotterdam moves its boxes with a level of digital transparency, speed, and environmental consciousness that most other global ports are still merely trying to imagine in their boardrooms. And the Dutch are absolutely not resting on their robotic laurels. Their current, all-consuming obsession is the creation of a massive digital twin. This is a staggeringly complex, real-time virtual representation of the entire sprawling port area. To constantly feed data into this massive digital brain, they recently launched an incredibly cool project, known simply as Container 42. The name is, of course, a delightful nod to the ultimate answer to life, the universe, and everything from Douglas Adams' famous book, The Hitchhiker's Guide to the Galaxy. Container 42 is widely considered the absolute smartest shipping container the planet has ever seen. From the outside, it looks exactly like a completely standard, boring 40-foot steel box. But on the inside, it is packed to the brim with hyper-advanced sensors that meticulously measure vibration, slope, noise levels, local air pollution, internal humidity, and precise temperature fluctuations. Since it was officially launched on its global mission in May of 2019, this hypersmart box has constantly traveled the world, endlessly collecting vital data on all the invisible, highly destructive physical forces that constantly affect cargo during global transport. The ultimate goal of this project is to provide the hyper-accurate, real-world data that the next generation of semi-autonomous cargo ships will absolutely need to safely navigate the oceans in the very near future. Simultaneously, the Restless Port Authority has taken a completely standard harbor patrol vessel, named the RPA-3, and entirely converted it into a cutting-edge floating laboratory. Packed with an array of advanced cameras and sensors, the RPA-3 is currently being used out on the water to actively train artificial captains. These are complex AI systems that are learning how to independently navigate massive ships safely through the incredibly crowded, chaotic waters of the port. By the year 2030, the port's grand ambition is to fully enable autonomous navigation throughout the entire complex, taking the humans off the boats just like they took them out of the cranes. So let us look back at where we started. We began with the terrifying crisis of the logistics wall. It was a massive crisis of global scale, where the relentless, unyielding physics of increasingly massive steel ships violently collided with the fragile biological limits of the human workforce. The problem seemed absolutely impossible to solve. How do you massively grow the port without slowing down, and how do you significantly reduce costs without completely sacrificing the safety of the fragile people who actually make it run? Through the wildly visionary bet-the-farm gamble of Gerrit Wormmeester and the unbelievable water-bending engineering prowess of the Dutch people, Rotterdam entirely reinvented the very nature of what a seaport can be. We have explored the silent, futuristic mechanisms of this total transformation. We have seen the remote-controlled STS cranes that finally bypass the dangerous whiplash limit of the human neck. We have marveled at the lift AGVs that expertly navigate using a completely hidden magnetic grid. And we have demystified the TEMS software that works tirelessly in the background to prevent catastrophic digital deadlocks in a massive, swarming hive of 70-ton robots. But that massive realization, the sheer undeniable fact that our creations, these megaships, simply became too large, too heavy, and too fast for the human body to physically handle, remains the most profound, thought-provoking insight of this entire journey. It forcefully reminds us that technological automation is not just a boring corporate strategy about efficiency or saving a few dollars on payroll. Sometimes, automation is simply about figuring out how to transcend our own squishy, fragile physical limitations. Today, as Container 42 quietly circles the globe silently gathering data, and as the very first artificial captains slowly learn how to navigate the cold waters of the North Sea, the Port of Rotterdam confidently stands as Europe's absolute largest entryway. And it holds that title not just because of its impressive geographic size or its massive land reclamation projects, but because when faced with an impossible wall, it had the sheer audacity and courage to step into the science fiction future first. The great global Tetris game continues to speed up every single day, but thanks to the Dutch, the robots are finally winning. So what do you think? As ships continue to get unimaginably larger and supply chains become completely reliant on artificial intelligence, will there ever be a point where a port becomes so automated that it is entirely vulnerable to a single software glitch? Or is the removal of human error the ultimate key to global logistics? Let us know your thoughts in the comments below. Thanks for listening and watching. Please like and subscribe, and make sure to check out our other videos about the global supply chain.